In this module, we shall start our understanding about the most widely adopted wireless technology on the access side, known as WLANs, and the standard which is adopted is Wi-Fi. We'll understand what are wireless LANs and how are they different from LANs. Then we'd have a look at the protocol stack and equate it to ISO OSI reference model. We'd look at a serious problem in wireless networks, and then we'll find out how Wi-Fi handles this problem. And then we'd look at a typical arrangement and topology of wireless LAN. Wi-Fi, as the name suggests, is wireless fidelity. Wi-Fi network is aimed at providing freedom to the users so that they can move about and they can come and go into the network with a lot of flexibility. An example could be, think about portable computers or laptops which come to a meeting. At that meeting place, when these laptops come in close proximity of each other, they form a local area network. Since they're wireless, it's called a wireless local area network. Look at the ease. There's no need to deploy cables, no need to deploy infrastructure which is complex as such. There is a particular type and a family of IEEE called 802.11, which is dedicated to doing standardization activity for Wi-Fi. Of course, you would have expected 802.11a to be the standard to begin with, but experience has shown that 802.11b has been a more adopted standard. It provides up to 11 megabits per second. It uses the same kind of frequency hopping that Bluetooth uses. Here, the frequency hops around 3 frequency ranges. The protocol stack in WLANs can be equated to the ISO OSI and the TCP/IP protocol stack by looking at the 802.11 functionality to be based on the data link layer. Since at the data link layer, the logical link control sublayer is still 802.2, so the only thing that 802.11 affects is the medium access control. At the physical layer, 802.11 supports both radio and IR. As you can observe, here at the physical layer, if it is using radio, then it is 802.11b, but if it is using IR, then it is 802.11 IR. But overall, generally speaking, when we refer to the Wi-Fi, we are referring to 802.11. Let's look at a problem which is of course not visible in wired networks and in single hop wireless networks, that is a single communication link. Since in Wi-Fi, we are expecting that we'd have multiple wireless computers, such as laptops, which would be communicating to each other. So a serious problem emerges. This problem is called hidden station problem or hidden node problem. From this hidden node problem, an equally important problem also emanates, that is called the exposed station problem. Let's see how this problem affects. Here we have A as a sender, C as a sender, B as a receiver. If A and C are not in communication range of each other, it actually means that there may be an obstruction, such as wall, that obstructs the EM signals to move from A to C and vice versa. Let's imagine that B is a node that is within the radio range of both A and C. Now you can observe that A sends to B and C sends to B. Well, it's fine, but what if they send simultaneously? So B will receive data from both, and consequently a collision is going to happen here. Now this collision is happening because A and C are unaware of each other's presence. Now, how does the problem get resolved with the help of Wi-Fi. Wi-Fi uses RTS-CTS mechanism. That is, here we have A and C as senders. So before actually transmitting, the sender sends RTS, that is request to send. Likewise, when B receives RTS either from A or from C or from both, it can behave in a certain rational and correct way. For instance, if A and C both send RTS, that is request to send, at the same time, a collision of RTSs is going to happen at B. Consequently, B would not respond, and A and C are going to back off, wait for a random time interval, and attempt again. When that happens, let's say A gets to transmit first. When A transmits request to send, B receives RTS from A and acknowledges A's request to send through clear to send. Now, when this clear to send is sent from B back to A, since B and C are also within the communication range of each other, so C is going to receive the CTS from B, and C is going to stop from transmitting, and it would be cautioned. The RTS and CTS mechanism includes who is going to transmit, that is, who is going to be the sender, and what is going to be the transmission duration. Using this RTS-CTS mechanism, Wi-Fi, in a very fine way, gets rid of the hidden terminal and consequent exposed terminal problem. Now let's look at the typical deployment and configuration of wireless LANs. Wireless LANs are based on a hardware device which serves as infrastructure for wireless nodes called the access point. If an access point has a certain group of nodes which are communicating to each other through it, then it is called a BSS, basic service set. Two BSSs, which are connected to the same switch. For instance, here in the distribution system, we have a switch, and let's say this switch is communicating to these two access points directly. In that case, both of these BSSs are going to form ESS, extended service set. Using this extended service set, these two basic service sets, along with their nodes, would be able to communicate with each other.